You just look at a couple examples.
Okay, I'm talking to Matthew here about limits. So this is the summary of what's going on. You have to memorize. These steps, this definition of the limit. It's the precise definition of limit, 1.7. So you have this abbreviation of for every. You have this abbreviation for there exists. That's epsilon. That's delta. And this much from here to here, to that period, is how we're doing precise definition of the limit. So memorize that, be able to use it, and you'll be able to get to a problem, first problem on the test. Now, we're going to have a quiz next week, and some of the stuff that you'll have will look like this. Limit as x approaches 7 of x minus 7 over 7 minus x, and you tried to substitute first, and you got 0 over 0. Well, 0 over 0 just means hope. Let's try some algebra. You can turn 7 minus x into x minus 7 by factoring out a negative 1. Well, now you can cancel x minus 7s by algebra, and that's the limit as x approaches 7 of negative 1, which is negative 1. So that's a limit problem for a quiz, but also, if you look at it in terms of what we're thinking about, it's you have a dangerous number, x approaching 7, but you can still say what the y-coordinate is as x approaches 7. So try graphing this on your calculator, and it'll look like the graph y equals negative 1, because that's what this answer comes out to be. As a function, x minus 7 over 7 minus x doesn't even exist at x equals 7. So it's got a hollow point. But we can still talk about the limit. The limit exists, because we're talking about what happens as we get close. As x gets close to 7, what does y get close to? Y is getting close to negative 1. So the other thing we did was this calculation over here for the same limit that we did by definition. We did a little calculation right here. So Laura chose epsilon to be 0.03 because epsilon has to be greater than 0. Epsilon has to be greater than 0, but small. We think of it as small. So 0.03, and our formula says delta, 0.03 divided by 5. Choose that for delta. Now that's 0.006. Well, x has to be within 0.006 of 3. So we went with 3.00579 to be within that much of 3. And we did the computation, and lo and behold, we came within 0.03 of 18, which is what's supposed to happen. So the meaning of this limit statement over here is as x gets close to 3, 5x plus 3 gets close to 18. And the closer x gets to 3, the closer 5x plus 3 gets to 18. So the limit must be 18. So put that all together, understand it, be able to do it.